Hello, everyone. Thanks for joining me in the last day of KubeCon. In the next 30 minutes, we're going to explore internals of Kubernetes to better understand how each Kubernetes component is coming after your pods and how they potentially pose a risk to your availability. A lot of what you're going to hear today is either hard-learned lessons from operating Kubernetes, or we proactively surveyed the code base to enumerate all the different ways Kubernetes can evict your pods. A little bit about myself. My name is Ahmet Balkan. I've been operating in Kubernetes open source space and container space since the early days of Docker. I contributed to Docker in its early versions, and nowadays I'm leading the Kubernetes infrastructure at LinkedIn. But probably if you know me at all, it's probably because of kubectx or Kubernetes or something like that. Can we get a quick show of hands, actually, who uses kubectx, Kubernetes? Good stuff, OK. Yes, this is my 6th time presenting KubeCon. So I want to talk about my employer and how I got into this rabbit hole. So at LinkedIn, we use Kubernetes to run our mission-critical services. We serve the LinkedIn website that you'll see and use, and we run thousands of microservices and large-scale databases on top of Kubernetes. And our fleet is pretty large. We have 500,000 servers in our bare metal data centers, and a significant portion of this is already on Kubernetes, and the rest is soon going to be all on Kubernetes as well. And I think this makes LinkedIn one of the largest Kubernetes installations in terms of compute footprint. And this is not our first KubeCon. We presented at KubeCon before. 6 months ago, we were at London. We presented our Kubernetes-based compute platform, how we actually use Kubernetes, how we deploy Kubernetes itself, and how we build a platform on top of it and offer it to thousands of engineers at LinkedIn. And a year before, we were at Salt Lake City, and we talked about how we treat Kubernetes, how we treat stateful systems on Kubernetes as a first-class citizen, and how we run stateful systems with local disks. So we're pretty invested in Kubernetes at this point, and we deeply care about the reliability of our compute stack. OK, coming back to the topic. So a harsh reality that we came to realize over time is that Kubernetes is your enemy if you care about your pod availability and evictions. Every single component in Kubernetes is trying to kill your pods, maybe except for etcd. Actually, we'll come back to it later. So these eviction features might not be the right thing to do for your workloads. And we'll go through these components and see how each of these components actually poses a risk to your website that you're running. So here are all the ways Kubernetes can kill your pods. But before we get lost in the sauce, I want to define what is an eviction, what do I mean by an eviction. So if an application stops on its own, if it says, you know, I'm just going to exit, or I crash because of a panic or an exception in my code, that's fine. That's just an application crash. But if it's Kubernetes stopping that application, I think that's an eviction, right? So if an app exits on its own, that's fine. We don't have a problem with that. But anything else killing our pods poses a risk to our application availability. And this is the list, to my knowledge. And that tells you all you need to know. Actually, I was just in a talk, and I just learned one more thing that I could add here potentially in 6 months, so we'll see about that. OK, so a while ago, we asked ourselves, what is the most important Kubernetes component that we are operating in our fleet? Is it the API server? I don't think so, because API server can go down, and your workloads are still going to keep running, right? Is it core DNS? Not really. We don't really use core DNS. We have our own service discovery system, whatever, right? Is it Kubelet? What happens if Kubelet goes down? Nothing truly happens. Your workloads still keep running. Or containerd can go down. Your processes that you started as a container, they're going to keep running, right? These don't really pose a big risk to the application availability that we have. You're still going to be able to type linkedin.com and go to the website. Well, it turns out, yeah, it's none of them. It's none of the components, but it's rather a property, which is keep running what's been running. Objects in motion should stay in motion, right? We don't want Kubernetes to bring down linkedin.com. And this is what the talk is about. And I don't think Kubernetes should bring your websites down either. So if Kubernetes messes with our workloads, we have a problem. So naturally, we care about pod evictions. And why do they happen? And ideally, we want all this to be in our control as much as we can. So first and foremost, evictions are a risk to availability, right? We don't want the website to go down just because some component decided this is a good idea to kill a pod. I'm just going to kill the pod. No, we don't want that. And the second thing that we want is to maximize graceful terminations. You start a request, suddenly you get like Chrome failed to load or whatever. That kind of sucks, right? We don't want that. We want the applications to terminate gracefully as much as possible, even during the evictions. You get to handle the termination signaling. You do want to do your shutdown. You want to drain your requests that are in flight and stop accepting the requests, unannounce yourself from service discovery, do whatever fancy thing you want to do. But if you have an option to gracefully terminate, let's do that, right? And then the third thing is, as I mentioned earlier, we run stateful apps on Kubernetes, and we are running them on bare metal. Like, we're running them on actual servers, no VMs, like directly. There's data on the local disk. Like, I gotta be on that machine to run that database. I can't just be moving around, right? And stateful apps are not like stateless apps. Like, it is, I think, pretty much true that Kubernetes is not really designed with stateful systems in mind, right? Like, we're gonna come to that shortly. I'm gonna show you an example, but like, if Kubernetes just decides to kill the last healthy replica of a database instance that has the healthy shard, we have a problem, right? And lastly, we have a lot of applications at LinkedIn because we're coming from a legacy world where people were used to running on the same machine for weeks and months. We ended up in a situation where we have a lot of applications that don't want to be moved around too much, like machine learning training jobs, or you can think of, for example, search application that downloads a large 30 gigabyte or maybe 300 gigabyte search index from somewhere, and they want to stay there, and they don't want to randomly keep getting moved around, right? So we want to minimize the movement as much as we can. So again, why do we care about like the node disruptions to begin with? Again, this comes down to the fact that we run on the bare metal. When you're in a cloud provider, they move you around. You never realize, right? They move you from one hypervisor to another hypervisor before even the TCP connection window closes. They're pretty good at that. They're just going to detach your disks. They're going to mount your block storage to another machine. It all works really well. But when you're on bare metal, you literally see every single failure that happened. And if you're running stateful, this suddenly becomes a problem. So we want eviction controls. We want to see exactly like who's going to disrupt our apps and when. So what does Kubernetes give you then? What are the eviction controls in Kubernetes? Well, there are very few knobs. It's mostly on and off knobs. There are some threshold knobs. We're going to talk about them. But the extensibility is limited. I can't say, hey, I have a stateful application, and I want to manage its evictions in a different way. I can't tell that to Kubernetes. So pod disruption budgets offer limited expressivity, right? And they're thinking that you're just developing a stateless application where every instance is just a replica of each other. But when you come to the stateful world, that's just not going to work. Like here, I have an example where a bunch of database pods are running. And if I kill the DB1 pod, which has the only available shard of the red triangle, right, that data is going to be gone. They're not going to be able to serve the database. Maybe the queries are going to start failing, whatever happens, right? So PDBs can't capture that as a requirement. OK, so the first area that I want to dig into is the API server initiated evictions. You all know the API server is Kubernetes control plane. And the most obvious example that we can think of is the pod delete API. I assume you all ran a kube control delete pod once. That's like one of the tutorials, I'm sure. It's all in there. This is the most basic way you terminate a pod on Kubernetes API. Again, pod didn't terminate itself. You terminated the pod, right? So the most interesting thing about the pod delete API is that like the controllers that you use to run your workloads, replica set, deployment, stateful set controller, right? Or whatever open source controller you brought into your ecosystem, this is the API they use to terminate your pods during a rolling update. If you're rolling a new version, your pods are just going to get deleted, right? This doesn't do PDB checks. There's no like availability check to verify this is, this pod is under-replicated, let's not delete that. So it's all up to the controller to decide what to do. You're at the mercy of the controller and not at the mercy of the API. So, by the way, I'm going to have demos, so eyes on the prize. Stay tuned. Pod eviction API. This is the second API that API server offers to remove a pod from the system. So this is a nicer kube control delete pod. So pod delete API still exists, but this is a wrapper on top, basically, that checks the pod disruption budget. All it does is literally goes to pod disruption budget, sees if there's, can I disrupt this application? If it says yes, it borrows one replica for disrupting it, and it goes and deletes the pod, and that's kind of the end of the story. Who uses this? Well, kube control drain command uses this. I'm hoping that most of you are not manually draining your pods, right? So when you use a cloud provider, they use this API as well when you like scale down your virtual machine pools or stuff like that. If you're using cluster API, similarly, CAP uses this as well. Well, this is going to be the last time you hear about the eviction API, unfortunately. This is a really nice mode of eviction. I wish everything worked like this, but this is the last time in this talk we're going to be hearing about this. Most eviction paths on Kubernetes don't use this at all. And how does this API work? Well, the way this API works is basically you just, you have a REST API call, you submit just like you submit a pod object, you submit an eviction object. It just looks like a real Kubernetes object. It has API version kind metadata that matches the pod that you're trying to evict, and you're submitting it to the /eviction subresource. Pretty straightforward stuff, right? This brings up a question. Can I write a webhook for this? We're going to come back to that. So the first demo that I'm going to show you is we're just going to evict the pod, see what happens. So I'm going to do a pre-recorded playing of a demo. So I have a pod. As you can see, the pod is running, right? And I started a watch in the terminal at the bottom. And now I'm just going to use a plugin called kubectl evict pod, and I'm evicting the pod. You see a bunch of events came to the watch screen that I had at the bottom, and I'm just going to scroll up to see what happened to the pod, right? And one thing I'm going to see that in the pod conditions, there's an eviction type disruption target. This is a feature that was added in 129. We're going to talk about it. And the reason is this is evicted by the eviction API. And you get some details about it. So this is a very nice way to evict a pod. You could just delete it, but hey, here's a nice way, and it tells you why it was evicted, right? So that's kind of the demo. So let's talk about the Kubelet-initiated evictions. This is interesting. So Kubelet is, as you know, is the agent running on the node, and what it's trying to do actually is to protect the node, right? It's trying to make sure the node itself is in a good state and it's not going crazy, and Kubelet is trying to protect its own integrity as well, and that's why Kubelet is actually evicting pods. And there are quite a few ways Kubelet actually can do that. So the first thing that we're going to talk about is the node pressure evictions. Basically, the Kubelet here acts as a proactive remediation agent on the node. Like it's trying to get ahead of things and act on stuff before the node actually gets in a bad place. So if you have resources on the node, right? You have memory, you have CPU, you have disk. Here, there's inodes, process IDs, and stuff like that. And you can run out of these things. And so before you run out of these things, Kubelet basically says, well, if the memory available is less than 200 megs, I'm going to start killing some pods, right? I'm going to start killing lower priority pods first. The problem here is that it doesn't care about your PDB. You have an application, its PDB is already violated, and if evicting that pod is going to make the situation worse, it's going to evict that pod. It doesn't care, right? So the problem here is, another problem here is that there are different thresholds to the node pressure eviction. Like there's hard thresholds and soft thresholds. If you hit a hard threshold right away, your pods are going to get killed violently and right away, right? Funny enough, this feature has so many knobs that you can turn. It's a fun feature to play with. We disable this because we do our own node health management in a different way, so we don't need this going around killing pods randomly. And again, like we get to keep control about who's killing our pods, and we just don't like this feature, so we just disable it. But what it's trying to do is protect the node so that the kernel stops killing your pods randomly, right? Okay, here's a demo. So what I'm going to show you here is that I have a pod that's already running, and I'm going to create a pod that just allocates a lot of memory. So as you can see, the pod exists already. I created the pod. So the second pod that I'm going to create is basically a memory hog. It's just going to start allocating memory, and let's see what's going to happen. So here's the memory hog container. There's a stress image I randomly asked ChatGPT to generate. I didn't really write this. I don't think I could write it. But one thing to note here is that it's running at a higher priority class. The last line, you see that it's like system cluster critical. So it's running at a higher priority. So it's not going to be the pod that's going to get bumped out. So as soon as I run this, right, what's going to happen is that the kubelet's going to start monitoring the memory of the node, which it's already been doing that. And I see that the other pod just finished. It got into the completed state. So it got terminated by the kubelet, right? So let's look at what happened. I was watching this node, watching this pod, and scroll up, and I see again the same condition, disruption target condition. Flip to the reason, termination by kubelet, and there's a message telling me that this pod got deleted or terminated because we were low on memory. So one thing to understand here is that this is a terminal state. When pods get completed or error state or whatever, like no is going to restart your pod, okay? Like you're stuck there. Unless you're using a replica set controller, deployment controller, something like that, maybe they will restart your pod, or they'll create a replacement pod, actually. They're not going to restart your pod. So anyway, we'll come back and talk about completed pods later. So the next topic that I'm going to touch is kubelet admission. This is a lesser known eviction mode. I don't think many people hit this because this is when you do weird things and so you suddenly realize that your pods are terminated, and this is one of the reasons why that can happen. So Kubelet has its own built-in admission checks. You know how the API server has various admission checks. You can't just provide invalid values on the API, right? Kubelet has the same thing. Like if I directly submit a pod to a node directly, if I say spec.node name is this node, Kubelet's gonna check, do I have enough CPU on this node? Do I have enough memory on this node that is available? If not, it's just gonna refuse to run the pod and transition it to that failed state again, that terminal state, right? So this can happen many other ways. Like a couple I noted here that there's a node affinity check. You specified an affinity role, affinity spec, right? And then you land it to this node. But if the node changed, and if you restart the kubelet, well, kubelet's gonna scan the pods, and it's gonna see that, well, this pod shouldn't be here. It's gonna just kill that pod, right? So what we found out, one time again, the hard way is that restarting kubelets in place is not safe. You should always try to drain before you upgrade your kubelet. It's not strictly necessary actually, but you should try to drain your nodes. But kubelet can get restarted other ways, right? Kubelet can crash itself. You don't have any control over it. So one of the ways that we got into this situation was that we were using node feature discovery, which is an open source component that goes and labels your nodes. But if you're using those labels for scheduling and the labels change later and the kubelet restarts, well, those pods are just going to terminate. So this is one way to bring your website down. So here's another demo. This is going to be fairly simple. So what you're going to see here is that I have the same pod, just a pod object. I have a node selector this time. I said role equals worker. So what we're going to query next is that let's take a look at what nodes we have available. So I type kubectl get nodes show labels. Rest assured, here's a worker node. It has the label role equals worker, right? So as you can see, as you can guess what I'm going to do next is that I'm going to create this pod. I'm going to just wait for that pod to come up. It came up correctly, right? And what I'm going to do is I'm going to delete the label on the node. Let's see if I actually do that. There we go. Kubectl labeled node. And then I do role minus, which is going to unlabel that node. So now I'm going to restart the kubelet and see if that pod at the bottom keeps running. So we restarted the kubelet came up, and the pod is completed now. It wasn't supposed to complete. Kubelet was supposed to just pick up that pod and run it, right? But no. So if you describe the pod, what you're going to see is that there's a warning saying that the node affinity no longer matches. Again, nobody's really going to fix this pod, okay? Like, you have to test these scenarios to see what happens in this case. Does my controller, does the controller that I use, is it actually going to fix that? Like, does the stateful set controller fix that? I don't think so. Okay. So the next mode that we're going to talk about is the local storage evictions. This is also a rather new feature in Kubernetes. You can set your pod spec in a way that if you use an empty dir volume, you can say, I want this volume to only get 1 gig. Not more than that, maybe like 100 megs. Similarly, you can set pod-wide ephemeral storage limits. You can say that, well, if I'm emitting too many logs, maybe I shouldn't be doing that. So you can say, my customers can only emit 100 megabytes of logs, right? So because the logs count towards your ephemeral storage. If you hit these things, again, your pod is going to get evicted. Let's see a quick demo of that. So I have an example here. So the pod that I'm going to use is just going to start writing files to the scratch space of the container. I'm just writing things to the local file system, temp file system, right? And I specified an ephemeral storage limit of, how much did I specify? 20 megs or something like that. So we're going to reach it pretty quickly. So as you can see, I just created the pod. Pod is running in the middle. And soon enough, there we go. The pod just transitioned into the error state. I think it just exited with an exit code 1 or something like that. That's when the error happens. But let's take a look at what happens in the watch screen. So I'm just zooming into that one. And I see a message saying that the reason is evicted on the pod. And the message is that, well, the local storage quota is exceeded, right? In this case, there's no condition on this pod, actually. We're talking about conditions, right? Like there's a particular condition that got added. In this case, it doesn't get added. That's kind of interesting. Maybe that's a bug. I actually didn't look into this. Maybe I should. Anyway, so let's move on. Let's talk about kubescheduler. You wouldn't expect kubescheduler to maybe evict pods, but it does, and it's a fairly well-documented mode, right? It's the pod preemption. Well, when we run out of space in the cluster, the scheduler tries to make space for a higher priority pod. And how does it do that, right? It tries to evict the pod. So there's another path, eviction path in the kubescheduler. And it honors the PDBs, but it honors them in a best effort basis, right? Any node where it basically scans all the nodes, and it tries to find candidates where there's no PDB violations, right? It tries to go into that node, evict that pod, fine, that's fine. And if it can't find that, it tries to go to another node where least PDB violations exist, and it tries to pick a pod there, and it tries to pick the pod with least PDB violations, but it'll violate your PDBs. And I think this is a critical thing to think about. And it gracefully terminates your pods. So again, very quick demo. I'm just going to create a pod. Pod is created. And I'm going to create a higher priority pod. Let's just do that real quick. There we go. The higher priority pod is created. And as soon as that happened, as you can see at the bottom, the original pod is deleted. So basically, that's how preemption works, right? And if I go ahead and describe the conditions, I'm going to see that the condition was set. The disruption target condition shows me the reason is preemption by the scheduler. So that's pretty straightforward. OK, we're coming to a juicy topic. Kube controller manager is that thing that keeps running in the background, has 40 different controllers running in the process, right? So it is also evicting your pods. And I think some of these ways that you already know. The first one is taint-based eviction, the no-execute taint, the dreadful no-execute taint, right? The nodes can get the no-execute taint for various reasons. If I'm Kubelet, if I stop reporting heartbeats, I'm going to go into the unreachable taint. That basically means, it's a weird name because the node actually might be reachable. It's just the node is unable to report heartbeats. There could be a permission issue. There could be a variety of issues where I'm unable to report heartbeat, right? And there's a not ready taint, and Kubelet checks its own health. Kubelet checks containerd, Kubelet checks CNI, and it tries to validate if all these things are functioning correctly. And if not, it's going to add the not ready taint with a no execute effect. So pods tolerate these taints. Typically 5 minutes is the default. But for the demo, I'm going to use a much shorter time frame. But the problem here is that sometimes the kubelet might be telling you a false signal, right? Containerd down, I don't think that should evict a pod. I want my pods to run if containerd is down, okay? I will find a way to remediate it myself, leave it to me. So if you roll your own taints, degraded node state might be okay, actually, for some applications, right? So again, quick demo. So what I have here is that I'm going to just run the regular pod that I've been running this whole time. It came up correctly, right? So I'm going to run a script to freeze the kubelet in my kind cluster. So the kubelet is frozen. I just sent a sig stop, right? I'm going to wait for a while. After missing a few heartbeats, by the way, I have a modified kind cluster here. Everything happens very fast. As you can see, the worker went to the not ready state, and the pod got into the terminating state. Obviously, it can't terminate because kubelet is down like this. It's just going to get stuck there forever. But eventually, I will unfreeze the kubelet, and as you can see, that little blip, that little kubelet freezing in place caused my pod to terminate. I don't like that. I don't want that, okay? So basically what happened here is that the taint manager went ahead and deleted the pod because of the no execute taint. Okay, this is interesting because you can actually do something about it. So thanks to Apple, as of Kubernetes 129 and 134 in GA now, there's a separate controller that manages adding the taints and executing, evicting pods based on those taints. So those two things are separate. You can disable one of them. That's great. We like that. Okay, this is the funniest thing. Pod GC controller. I bet you never heard of that one before. Have you ever wondered what happens if you delete all your node objects? Who has ever done that? Look at here. So think about who you are giving access to in your API, right? One time I wrote a controller that manages the nodes, and I accidentally pointed it to production. And there's something that happened, and I call it the mass descheduling event. So the pod GC controller, anytime the node is gone, those pods are now orphaned. It's going to wait 60 seconds, and if the node doesn't come back, goodbye. So if you're managing your own nodes, which we do in our bare metal installation, we have a node lifecycle controller, you should implement guardrails. You should throttle how fast the nodes can get deleted and things like that, so that the node objects don't get nuked. By the way, if someone goes to etcd and deletes the nodes, the same thing is going to happen, so be careful. So let's just see that. Obviously, this demo is going to take 60 seconds, but I'm just going to speed it up for the sake of time. We deleted the worker node. Here we go. The node is gone. But the pod is still there. It shows running. Actually, the kubelet can't do anything anymore because the time, like the Kubelet's credentials are revoked at this point. So like whatever we're gonna see is like not the, Kubelet can't do anything at this point. It's never gonna terminate that. But if you wait long enough, let's see what happens. The pod's still running, and then it's deleted. You see, it wasn't even terminated. It just got deleted like right away. So anyway, so what can you do about these? Here's the interesting part. Number one, eviction interception. So you can write a webhook for your eviction calls. This is a slippery slope. You know, we don't recommend this to everyone. We found use cases for it because PDBs are insufficient. People want to have custom eviction policies. Some customers actually want to use eviction signal, and they want to start moving the data out and eventually approve the eviction request. You can actually use eviction request as a signal, right? So anyway, whatever you do, just make sure to don't intercept all objects because the eviction object doesn't have labels or anything. So it's gonna evict, like it's gonna intercept. You can't use object selectors on it. You can't say I want like only these type of pods to be intercepted. So you'll figure it out, I'm sure. Anyway, this is something new that's coming up in the node lifecycle working group. There's a KEP. It's gonna go alpha in 135. You can specify eviction interceptors on the pod. You can say, here are 3 eviction interceptors, go through them, see which one is interested in the pod, and let that thing evict the pod instead of you evicting the pod. And eventually, the pod will just disappear if one of them actually gives a thumbs up and evicts the pod. This is a long KEP I recommend reading if you're actually interested. So we talked about pod disruption conditions. Funny enough, these conditions get added to the pod right before the pod gets deleted, so you can't really like observe it by your eye. What we do, and like something that's been an indispensable tool operating Kubernetes in production, is to collect audit logs and events. Collect these things, log all the pod response bodies, request bodies. It's worth the storage money that you're gonna pay on them. You can actually debug things. And lastly, this is the picture slide coming up. I'm going to leave you with this cheat sheet. If you're going to take a picture again, this is the one to take a picture of. This tells you, who honors PDBs, who doesn't. Is it a graceful termination? Is it sometimes graceful termination? So this is all the stuff that we just talked about. And lastly, I'm going to come back. There you go. Get it in. All right. So let's talk about eviction threshold settings. Adjust them if you care about them. Do disaster recovery drills. Take down your control plane, see what happens. Just bring it down, see if your pods keep running. If you're running stateful, see if your toleration settings are correct, if you're tolerating long enough, the right taints, whatnot. If PDBs are not enough, maybe like write your own PDB controller. It's not rocket science. And understand what happens when a single pod goes to a terminal state and stays there for a long time. You can end up with 10,000 finished pods. Nobody might be cleaning up, but there's a controller that does that. Actually learn about it. So thanks for coming. Hopefully it was useful. So I'm going to leave you with 2 things. One of them is the same thing I just talked to you about. It's in a blog post format. It doesn't have all the details that I just talked about here, actually, but it's long enough. So that's the QR code for that. Second thing is we're operating Kubernetes, and it's a hard deal to deal with all these interesting problems. So if you're interested in going really deep on Kubernetes, if you want to join us at Kubernetes Infra team at LinkedIn, scan the QR code. We have a job opening. Yeah, thanks for coming.